Hey everyone, it's your captain speaking, and we're going to play a little bit of one of my most entertaining space simulators. It's not so much a game as it is just a space explorer. It's called Space Engine. And as you can see, we are rotating. No, we are not rotating. We are floating above a planet. Not of this, not of our solar system, that's for sure. I don't exactly know where to begin with this one. It's got purple rings, which is pretty cool if you ask me. What is that? Cluster NGC 6712. It's a globular. I think it's like a small galaxy of very dense stars. That's what it looks like anyway. So let's see. We can actually zoom in. This game hasn't had an update in months, which is sad, but the last update was in last July, and in that update you can actually zoom in on these rings of this strange Earth-like planet with rings, and it actually simulates volumetric rocks, which, if you didn't know, rings from planets are made from asteroids, basically. And here we go. Well, they're moving very fast. We might have to pause time. Here's the little rocks I was talking about. Now, if you can see right here in the top left middle, just top middle, sorry, it'll show the speed that I'm changing with my middle mouse scroller. So if I scroll back, it slows me down. If I scroll up, it speeds me up. And we can go up to thousands of times faster than the speed of light, which is still pretty slow. As far as the galaxy is, as far as the universe is concerned. So these are the little tiny I don't know why they're purple, actually. You know, I don't know if that's just the lighting of this. Where's the star of this place anyway? Well, it looks like just a regular sun type star. No, it's apparently a red dwarf. That's not red for sure, but I'll take your word for it. Anyway, enough of that. Actually, if we start it again, you can see just how fast these things are actually going in real time. Let's head on over to the planet's surface and see what we got. This is a beautiful planet, by the way. Holy shit, it's nice. Here's a storm. Wanna go in the storm? Let's go on this little island right here first. Well, did I say little island? Holy cow. No, I meant a huge-ass island. Huge. You know, I'm really looking forward to the day that they add grass and... Well, there's a mod for grass, but apparently it's like 1.7 terabytes, so I said... Probably not going to download that. I don't even have 1.7 terabytes on my hard drives. We'll have to wait till they start... I mean, like, if they started adding, like, trees and grass and stuff to these Earth-like planets, that would be just awesome. But hey, this is not really what this game's about, really. It's not really about getting close to the surfaces, necessarily. I mean, it's cool that you can do that. But what it's really about is exploring space. Let's go look in that. Where's that storm? Here it is. Oh. Oh! You know, this right here just freaks me out. Like, the fact that you can go under the water. No, thank you. Oh, no. I don't want to be down here. Like, this scares me more than some horror games. Like, just being under a deep, dark, empty ocean. It freaks me out. Like, I get scared being alone, like, at my house sometimes when I do this kind of stuff. Flying around in space, it's scary. It's also very humbling because we just realize how small and completely insignificant we really are. This is a black hole right here. Speaking of black holes, definitely not gonna. No, is that the? Definitely not gonna be in the water at night. And here we go. Okay, so as you get closer to it, it turns red, so that makes sense. If you really want to see how absolutely huge... Oh, this is red dwarf. Okay, this one's not that big, actually. Anyway, this is what the surface of a star looks like, essentially. Pretty much just what? Plasma? I mean, I really don't even know what plasma is. Like, I know so many scientists watching this video, a massive amount of scientists watching this video are going to be yelling at me, but what is plasma? I mean, it's like, it's one step further than lava, or one step further than fire, and I don't even know how, my brain doesn't even know how to comprehend that information. What was that? I saw a nebula, I think. It didn't have a name for it, though. We're going to go to it, though. Let's see. Now, as you can see, these things shooting by now are actual stars. So that's how fast we're going. We're going 21 light years per second. Which is so far beyond possible that it's impossible. It's extremely impossible. Interesting fact, a lot of nebulas are actually made out of exploding stars. When a star gets old enough, or it gets unstable enough, it explodes into a supernova, and that supernova leaves behind basically what amounts to gases and clouds of awesome colors, and they make shapes in the sky, in space, and that's what this is. This is a giant cloud left over from a supernova. And you got some new stars being formed in the center of this, looks like. And perhaps, possibly a black hole somewhere in here. If you're not careful, you will zip right by these things. That is not a black hole, that is a... Whoa! Yeah, don't right-click. You rotate around whatever you've clicked on. What's this? I think that was the same cluster we were looking at before. Let's go! 529 light years per second. Whoa! Okay, that wasn't it was not a galaxy. It was in fact just a cluster, a very thick clump of new stars, young, hot stars. Trying to find a black hole in this is very hard. Actually, I think I might have found it. Hold on. No, I think that's just another star. Maybe. What the fuck is this? Is this a black hole? Have we found the black hole in the center of this cluster? Oh yeah, we have. Cool. Pretty sure. Oh yeah, this is a black hole. What's insane is that a couple years ago, or a year and a half ago, I can't remember how long ago, we have literally discovered, we've taken a picture, an actual photograph of a black hole. And it is no longer a theory in science, it is a fact that black holes exist, and they are scary. I can't even see it. It's so bright. You think of being a black hole. There it is. I think being a black hole would be dark, but not the ring around it. This always freaks me out too. And there we are. We're inside the black hole. Oh, it's moving. Okay, we're gonna hit pause on time, because if we don't, we're gonna get lost in this black hole. I've done that before. It's scary to get lost inside a black hole. Perhaps one day we'll have the technology. And we're out. Perhaps one day we'll have the technology to go inside a black hole. Well, actually, first of all, let's get the technology to get to a black hole first, and then we'll get the technology to go inside a black hole. It's so easy to zoom right past these things when you're going a certain speed. It's like a white main sequence star. Okay. Nice. You know, actually, did you guys know that the majority of stars in the sky are actually binary stars? So there's two stars circling each other. There's not a whole lot of stars that are single like ours is. So that's kind of cool. We're kind of unique in that way. Okay, getting away from this cluster. There's that nebula that we were at. It looks like the Rose Nebula, honestly. I actually just made that up. I don't even know if the Rose Nebula is a thing. But if it's not, that should be the Rose Nebula. Because it looks like a rose. At least I think so. Okay, so let's, how do we, forgot how to, okay, search for Earth. It is let's see. Distance 22,000 light years away. What galaxy are we in? Oh. No. Okay. It's a lot closer than I thought. We're in the Milky Way. Actually, what you're looking at here is the sun. Whoa, whoa, whoa! Woo! Okay. What do we got here? What's this? Wait a minute. This isn't the sun, is it? No, this is a blue main sequence star. Where the hell did it take us? Hold on. This isn't right. Earth. Strange weirdo. Don't know why that was a thing. Zoom on up and get past these stars here. Are we in the... Yes, we are in the Milky Way. Oh. Okay. Now we got the right... Yeah. Temperate marine terra with life. That it does. It's got quite a bit of life on it. Hopefully for millions of years to come, but we'll see. Jupiter. They consider planet Jupiter a cold Jupiter. It's like it is a Jupiter. It's not a cold Jupiter. It's a Jupiter. So let's go to Earth. See just how minute and minuscule and small we really are. If you guys want to see a comparison about how far away the Earth is from the moon, that's the moon. That's Earth. And it blows my mind that little tiny creatures on this planet sent a rocket ship from here all the way to here. So far away in space. Look at all this space between there. And then we came back and survived. And that blows my mind that we've done that. There's Earth. And this is, what time is this? 11:07. Oh, okay, so it saved it from where I was before. It looks like I went into the future quite a ways. So what we can do is set normal time speed. Well, I think that's already normal time speed. Set current time. Oh, okay, so since we did that, it's now currently in a completely different part of the circulation around the sun. You can really just see how skewed the sun is right now. Like the shadow of the sun during the winter time. So instead of going like perfectly west and east, instead of the light being like split like this, in the wintertime it's split like this because the sun tilts, the Earth tilts on an axis. And during the wintertime it's tilted a certain way, and it makes the shadow of the sun a different angle. And I, for those of you who care, I am right in here somewhere. Yep, this is my home. Looks a little different when I look out the window, but more or less that's it. Alright, let's leave Earth. Let's go explore the biggest star that we know of. Yes, okay, so UI Scuti, or Scuti, I don't know how you pronounce that. Scudi? Is not necessarily, I think Stevenson something is the largest, possibly the largest star, but this one is like as well up there when it comes to like extreme bigness. And if you look at it, it's not really even that far away from Earth. Now, these things are gargantuan. They're actually hypergiants. It says supergiant, but they're actually considered hypergiants because they're so big. They're literally thousands and thousands of times the size of our sun. Oh, wow. And they're just bulging and they look like they're ready to explode, honestly. So we zoom in here. We just hit the surface. If you look up here, 1.583 kilometers per second, 10 kilometers per second, 100 kilometers per second. I am moving forward right now. This is me moving. I'm moving 100 kilometers per second. What is that? 60 miles per second is how fast I am moving with the W key right now. This is us moving at 7,943 kilometers per second. Doesn't even register. And an astronomical unit is the distance between the Earth and the Sun. Oh, that's how fast we were going. Hold on. We're going between the Earth and the Sun every second. And that's how fast we're going here. And that's how big this thing is. A hot sub-Neptune. Well, Neptunes aren't very interesting. They're just gas, right? Here's a super Terra. This is a torrid, arid super Terra. Oh, it was. Hold on. There it is. It's got a bunch of moons. Look at all those moons. Now, you wouldn't want to live on this planet, of course. Let's see. Where's the temperature? Look at this temperature right here. Okay, guys, look at this. Temperature of this planet, this close to the one of the largest red supergiants, hypergiants in the galaxy, is 1,694.3 Celsius. Like, how is it not just a ball of magma? Let's say if you could withstand 1,500 degrees Celsius. And you could live on this rock. Somehow. Which we're going to try and land on here. Whoa! I thought that was the ground. Nope. That was another cloud layer. Okay, so as you can see, the ground is more or less very liquidy. So, I mean, just standing on it, you'd catch immediately on fire. But let's pretend like we were in a airplane above the cloud layer. When the sun rose, this is what you would see. That's the size of the sun on this planet. It just... so much of this just blows my mind. Anyway, this has been a look at just a couple out of millions and billions of things that you can find in this simulator, which I think is one of the coolest simulators. I'm going to do one more experiment with you here. So, this is our sun. I'm going to zoom out slowly. I'm going to show you the size of the universe. There go the planets. And there's our star. That is our star. That's our home. And we're starting to move fast enough, 2 light years per second, to where the other stars start fading away from us too. You can start seeing the center of the galaxy over there, where it's just thicker stars making it brighter over there. And all the clouds, gases circling around our Milky Way. This is our Milky Way right here. And you can start seeing some local galaxies that are close to us, like this one and this one. There's Bernard's galaxy. Milky Way. And all these aren't stars anymore. These are all galaxies that are flying by us. We're now going 52,000 light years per second. Currently going as fast as we can in this game at 326 million light years per second, I believe. And there it is. The edge of the observable universe. We can't see anything else beyond that. But as far as we know, it could keep going on and on. We can't see past this wall because light is so slow. The light beyond this wall hasn't even had time to reach our planet. Thank you guys for watching. If you liked that video, please like and subscribe and leave a comment. And I'll see you in the next one. Stay toasty, everybody. See ya.